The question is, consider the following recursive C function that takes two arguments, unsigned int foo of unsigned int n, unsigned int r. If n is greater than 0, return n modulus r plus foo of n by r, r, else return 0. So this is the program based on which the question is, what is the return value of the function foo when foo of 513, 2 is called? Option A 9, option B 8, option C 5 and option D 2. So basically this is a recursive function because the function is foo and we call the same function within the function. So we can solve this problem using the recursive tree. So the first call is foo of 513, 2. So n is 513 and r is 2. So we see that if n is greater than 0, here n is greater than 0. 513 is greater than 0. So we return 513 percentage 2 plus foo of 513 by 2, 2. So percentage is basically the remainder function. So 513 percent 2 is the remainder when 513 is divided by 2. So the remainder is 1. So we have two returns. So 1 plus the other part is foo of n by r, r. So foo of 513 divided by 2 is, we have, since both are integers, we should just take the integer part. So 513 divided by 2 is 256. It's actually 256.5, but we should take only the integer part. So 256, r is 2. So we keep solving the recursion. So now this is again called, again n is 256 and r is 2. So 256 is greater than 0. So we return 256 percentage 2 plus foo of 256 by 2, 2. So 256 percentage 2 is, the remainder is 0 plus 256 divided by 2, 2. So foo of 128, 2. So this goes on. Basically we see we have to get the remainder when this is divided by this. We get the remainder and then we divide this by this and r is 2 always. So basically the next step will be 0 plus foo of 64, 2. 64, 2. So this goes on. Next it will be 0 plus 64 by 2 is 32. So it will be 0 plus foo of 32, 2. Again this will be 0. 0 because 32 divided by 2, the remainder is 0. 0 plus foo of 16 divided by 2. This will again be 0 because 16 divided by 2 remainder is 0. Plus 16 by 2 is 8, 2. It will be 0 plus foo of 4 by 2, 0 because 4 divided by 2 again the remainder is 0. 4 by 2 is 2, 2. 2 by 2 the remainder is 0. Now it will be foo of 2 by 2, 2 which is 1, 2. So now this should return 1 plus remainder something. So this will return 1 by 2, the remainder is 1 plus foo of 1 by 2, 2. 1 by 2 is the integer value of 1 by 2 is 0. So it will be foo of 0, 2. So now n is 0 and r is 2. So we come here, we see that if n is greater than 0, we return this, else we return 0. Now n is 0 in our last case, so we have to return 0. So this returns 0. So basically this is a series of additions of the remainders. So it will be 1 plus 0 plus 0 plus 0 plus 0 plus 0. We go all the way plus 1. So the final answer will be 1 plus 1 which is equal to 2. So this will be the value that is returned when 513 foo of 513 comma 2 is called. So the answer is option D, 2. The second part is, what is the return value of foo when foo of 345 comma 10 is called? So again we solve this using the recursion tree method. So first foo of 345 comma 10 is called. So 345 is n and 10 is r. So n is greater than 0. So we return n modulus r, which is 345 modulus 10. So when 345 is divided by 10, the remainder is 5. So it will be 5 plus, you return foo of 345 divided by 10 comma 10. So that is foo of 34 comma 10. We take only 34 because it's integer by integer. So again we recursively call this. Now n is 34 and r is 10. Again 34 is greater than 0. So we return 34 modulus 10, which is 4, plus 34 divided by 10 comma 10. So that is 3 comma 10. So foo of 3 comma 10. Now this is again n is 3 and r is 10. So n is greater than 0, 3 is greater than 0. So we return 3 modulus 10, which is 3, plus foo of 3 by 10 comma 10, which is foo of 0 comma 10. So now n is 0 and r is 10. So the if condition is not satisfied, it goes into the else condition. So since n is 0, we return a 0. So the final answer is 5 plus 4 plus 3. So the returned value when foo of 345 comma 10 is called is 5 plus 4 9, 9 plus 3 12. So the right option is option B, 12.